Hi, welcome to this lesson on calculus. What is the derivative? Let's have a look at deriving from first principles, question 2. So again, the first derivative is defined as the limit as h tends to 0 of the average gradients formula. Alright, so I'm going to do my algebraic gymnastics on the side and work out what this expression is. Okay, so first of all, f of x is equal to 2x squared minus 3x plus 5. So what is f of x plus h? So wherever there's x's here, I need to replace them with x plus h's. So that's going to be 2 times x plus h all squared minus 3 times x plus h plus 5. So let's simplify this. While squaring it, I'll have x squared, double the product, so plus 2xh, and then plus h squared. Then if I distribute that out, I get minus 3x minus 3h, and then plus 5. So lastly, if we expand out the 2, so I get 2x squared plus 4xh plus 2h squared, minus 3x minus 3h, and plus 5. So let's see what cancels and what cleans up here. All right, so that's f of x plus h. It doesn't look like anything really cancels or cleans up here nicely for this one. So what we'll do next now, so let's get another color. All right, so now we'll do f of x plus h minus f of x. So this is where terms will begin to cancel now. So it's equal to 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5. So you can see why I call it algebraic gymnastics, because there's so much algebra going on, and that's where students often make mistakes. All right, so that is why we need to make sure that when we're writing out these terms algebraically, that we keep good track of them. Right, and then that's minus f of x, which is 2x squared minus 3x plus 5. So let's see, the 2x squared will cancel with that 2x squared. Then I'll have negative 3x minus 3x, so that's negative 3x plus 3x, that will cancel. And then the 5 minus the 5 will also cancel. So I'm left with 4xh plus 2h squared. All right, so that cancels out very nicely for us. So now this is equal to the limit as h approaches 0 of 4xh plus 2h squared. All right. So now, all over, let's just make sure we haven't left anything out. Very good catch. You see. Okay, so I saw there's a minus 3h here as well. Okay, so that is all the terms there. So let's go ahead and put that back in, minus 3h. All over h. Now, on the numerator, we can pull out a common factor of h. So if I do that, I get 4x plus 2h minus 3. Okay, all over h. So now these h's will divide into each other. Now I have the limit as h approaches 0 of 4x plus 2h minus 3. So at this point, we can now evaluate the limits by directly plugging it in. So it's 4x plus 2 times 0 minus 3. And that just leaves us with 4x plus 3. So isn't that interesting? We started off with this quadratic function, 2x squared minus 3x plus 5. Okay, so because it's got a positive 2 in front, it's going to have that shape there with a minimum turning point. And the y-intercept is going to be, at x equals 0, it's going to be 5. So we're just going to do a rough sketch. And then the turning point is x equals minus b over 2a, which is negative 3 over 2 times 2. So that's 3/4. So at 3/4, you're going to have your minimum turning point. So the graph will look something like this in shape. Okay, so that's the graph f. So we are saying that the derivative of this quadratic function, the derivative, is now a straight line, a linear graph, 4x plus 3. That's very interesting. We started off with a second degree polynomial, and we end up with a first degree polynomial when we take the derivative. So what's actually interesting is that there's a derivative law called the power law, and that's what we will look at when we do the derivative laws topic. But it's to get you starting to think about it now, looking at patterns and seeing what happens when we take derivatives of functions. And again, the straight line is telling us the rate of change at any given point, right? The tangent lines, what are happening. Okay, so the rate of change is 4x plus 3 for all these x values here, these tangent values. All right, so these tangents, they'll have gradients, and the gradients are measured by 4x plus 3. So for example, if you look at x equals, let's say 7 over here, then the gradient will be 4 times 7, which is 7, 14, 21, 28, plus 3 is 31. So it has a positive gradient, and you can see that by the tangent line, it's got a positive gradient. If you took x equals -1, for example, which is over here, can you see you have a negative gradient? So if I put x equals -1 into this, then I have -4 plus 3, which is -1. So the gradient at -1 is -1. Okay, so again, that's the interpretation of what the derivative is actually saying with respect to a function. How the function grows, its rate of change at a singular point. All right, I'll see you in the next one.